All right, hey everybody, hope everybody's doing good today. Um, Here we are, properties of parallel lines. This chapter is about parallel lines, so let's get to that. I'm wearing a hat, and I apologize for that. I'm not a dress code, but hopefully that won't distract you. Okay, we've learned about transversals and then these types of angles. Let's see, why we learned those to begin with. If you have two parallel lines that are cut by a transversal. So over here, which one would be the transversal? Line C has these two intersections. So we're talking about line C. And then these are parallel, thus marked by those pointers there. Then corresponding angles are congruent. Okay, now this is the first huge part that will lead us to everything else in this section. So where are the corresponding angles in this diagram over here? All right, if we have angle 1, what is in the same relative spot as angle 1 in this cluster of angles? Angle 1 is on the upper right hand side, so is angle 2. So those two angles, angles 1 and 2, are corresponding angles, and because those lines are parallel, those are congruent. They're equal to each other. I'm going to fill in these other angles here just so we can talk about the other pairs, because there's not just one set of corresponding angles that are congruent. Because those lines are parallel, angle 5 corresponds with angle 4. They're in the same relative spot. Angle 3 and 7 are congruent, and angles 6 and 8 are congruent. So when you have parallel lines in a transversal, you have 4 sets of corresponding congruent angles every single time. Every time you have parallel lines, corresponding angles will be congruent. Now over on the left hand side for the reason column, this is what will show up as your reason in a proof, like what we've been doing. Here's the shortened version of this. Just write parallel lines, comma, corresponding angles are congruent. That is much easier than writing everything out. Okay, so now we're going to use that to build on it. The next piece of this is if we have two parallel lines cut by transversal, same scenario here, then alternate interior angles are congruent. Let's talk about why that is the case. All right, if we got angle 3 right up in here, angle 3 we know is congruent to angle 1 for the reason of, yep, that's right, they're vertical angles. So angle 1 is congruent to angle 3. That's the same angle 1 that's congruent to angle 2 up here. So by virtue then of vertical angles and corresponding angles, substitution if you will, we were actually doing the proof. That's how we would prove that angles 3 and 2 are congruent. It's a pretty easy proof actually. So these alternate interior angles 3 and 2 are congruent. Well, what about 6 and 4? Well, those are alternate interior angles as well. They are congruent as well. So with every set of parallel lines with a single transversal, for each transversal and set of parallel lines, there's going to be 2 pairs of alternate interior angles that are congruent. To abbreviate that, you will write parallel lines, comma, alternate interior angles congruent. That is how we will say that reason. Okay. Moving on, if two parallel lines are cut by transversals, same scenario here, then what was the other type of angle relationship that we learned last section? That's right, same side interior angles. So what will those be in this case? Well, if we start with angle 3 up here, what do we know about angle 3? Well, angle 3 is congruent to angle 1 and angle 2 and angle 7 for that matter. But angle 3, how does it relate to angle 6 or angle 5? Angle 3 and angle 6 form a line together. They are supplementary. They are a linear pair. Angle 3 and angle 5 are a linear pair. So how does 3 compare with its same side interior partner 4? Well, if 3 is supplementary to 5, and 5 is congruent to 4, just like we said up here, 5 and 4 are corresponding, then 3 and 4 must also be supplementary. Remember, if an angle is supplementary to congruent angles, then they're congruent. Okay, so same side interior angles, the short version of it is that they are supplementary. So in this case, angle 3 plus angle 4 equals 180. And what's the other set of same side interior angles, angles 2 and 4. So for every set, we have 2 pairs of same-side interior angles as well. Parallel lines S-S int sup will be your abbreviation for that. Now before we go on to the next one, I want to talk about what's going to happen every single time we have this diagram. This is going to happen a lot here, folks, with the parallel lines, transversal coming through the parallel lines. Alright, if we start with angle 5 up here, how does angle 5 relate to angle 6? They are congruent because they are vertical. How does angle 5 relate to angle 4? They are congruent because they are corresponding. And angle 4 goes with angle 6. They are congruent because they're alternate interior angles. And then that's congruent to angle 8. 8 and 4 are vertical. 6 and 8 are corresponding. So 5 is congruent to 6, which is congruent to 4, which is congruent to 8. All of those are congruent. Okay? Every single one there in yellow is congruent to each other. And then what does that make? What's left? Well, what about 1, 3, 2, and 7? Well, 1 is congruent to 3, which is congruent to 2, which is congruent to 7. And they're all vertical angles, alternate interior angles, corresponding angles with each other there as well. And then what is true about each pair? If these are yellow and these are red, this is a linear pair. Those are supplementary. 5 and 1, supplementary. 1 and 6, supplementary. 6 and 2, same side interior, supplementary. 3 and 4, same side interior, supplementary. 5 and 7, by virtue of substitution, are also supplementary for the same reason that 5 and 3 are supplementary. Okay? So that's going to happen every single time. You'll see that again. There's one more theorem that happens. We'll prove these at a later date. But if you have a transversal, if a transversal is perpendicular, as we have here, transversal L is perpendicular to J, and J and K are perpendicular, then it must be perpendicular to the other one as well. This makes sense too. These are corresponding angles, right? So if that's 90 degrees, then that's 90 degrees. Or if that's 90 degrees, then this angle here is 90 degrees, and those are supplementary, which means it's 90 degrees, and so all those angles everywhere are 90 degrees, 90 degrees, 90 degrees. Here's the abbreviation. We're just going to use symbols over here for this. We're going to say if you have a perpendicular line that crosses parallel lines, then it's perpendicular to that as well. So perpendicular to parallel makes perpendicular, is what that is intended to say. All right, first set of questions. I'm going to do this set with you. Name 7 angles that must be congruent to angle 1. Well, what we have here are 2 pairs of parallel lines. So we have, well, each of these lines is a transversal for each of the other lines that are connected here. So name the 7 angles that are congruent to angle 1. Well, if you start with angle 1, angle 6 is vertical to it, right? And then what about 9 and 3? Those are both corresponding to angles 1. Also, 9 and 3 are alternate interior to angle 6. So 9 and 3 are congruent. 8 and 14 are vertical to 3 and 9. 11 and 16 are alternate interior and corresponding to those to 8 and 14 now. So what we end up with is that the 7 angles that are all congruent then, because they are parallel lines, all of those red angles are congruent. 6, 9, 14, 3, 8, 11, and 16. Okay, so what are the 8 angles that must be supplementary to angle 6? Let me see if you can answer that before I do. Okay. Angles 2 and 5, 10, 13, 15, 12, 7, 4. Of course, the order doesn't matter. Any of the other ones, they are all supplementary. They're all equal to each other as well. So then, in this diagram, if measure of angle 5 is equal to 60 right in here, what are the measures of the other numbered angles? Well, all of the ones that I marked in green, 2, 5, 10, 13, etc., though all of those have to be 60 degrees. And then all of the red ones are going to be supplementary to those. They all have to be 120 degrees. So it's not like there's a lot of work that goes on in finding those angle measurements. Okay, for numbers 1 through 8 right here, your job is to determine for what reason is this statement true. Now, our reasons now are going to be ones that we've had from the past, and ones that we've added. There's 4 new reasons that we figured out at the top of the page. See if you can figure them out. I'll help you out with 1 and 7. How's that? Sorry, number 1. Angles 3 and 7. Those are corresponding angles. Angles 3 and 7, because we have parallel lines right here. 3 and 7 are corresponding. So your reason is parallel lines, corresponding angles, congruent. Try the other 7, please. Okay, did you see how these things are related? Number 5 is vertical angles. Has nothing to do with the new ones. That's ones we've had before, but the others were ones we've had. Now, down here, we got 2 pair of parallel lines, like what we had before. So, like I was showing you, we have all of these angles right here are going to be congruent, and then all of these other angles are going to be congruent and supplementary to the purple one. So I got purple and gold angles here that are all congruent and supplementary. So what's the measure of angle 2? If 1 is 120, well then every single one of those purple ones is equal to 120. And then all of the gold ones are equal to 60. So what's angle 2 equal to? 120. You keep going. $60, 120. See, that's easy peasy. All right, so you do 13 through 15 right here using the same technique as what we just did. How'd you do? Yes? No? Maybe? We'll see. Now, number 16, let me do it for you, and then you do 17 on your own. This one tricks people at first, but this gives us information about angles 3 and 4. How are 3 and 4 related over here? Those are linear pair supplementary angles. So we can write this. Angle 3 plus angle 4 equals 180. Make sense, I hope? Well, and now I'm going to use substitution and say, well, what does angle 3 equal to? Angle 3 is equal to angle 4 plus angle 30. So I'm going to replace this angle 3 with measure angle 4 plus 30. Now I have basically done an equation with just one variable. My variable is the measure of angle 4. I can have 2 of them. Measure angle 4 plus measure angle 4 is 2. Measure angle 4, just like x plus x is 2x. Subtract 30, I'll divide by 2. The measure of angle 4 is 75. But wait, what did the question ask? The question asked, what's the measure of angle 5? Well, how is angle 4 related to angle 5? Well, angle 4 is congruent to angle 2, which is congruent to angle 8, which is supplementary to angle 5. Therefore, angle 5 has to equal 105 degrees. You try number 17. All right, did you get 100? I hope so. Hey, just see so I can know you're paying attention. This looks kind of like a thing of tic-tac-toe. Make an X, an X, and an X, or an O, and O, and O, like you've won a tic-tac-toe right there, just for fun. Let me do these 2 examples with you here, example 1 and example 2. This is now an application of these questions where we'll be solving for variables. To solve for X, how does it relate to angle 105 here? We got the parallel lines, transversal, 3x and 105. Those are what type of angles? That's right, corresponding angles. So 3x equals 105. Those are congruent. X is 35. What about the solve for y? How does 5y go with 105? Well, those are same side interior angles, so they're supplementary. Y is equal to 15. Question B down here has got a little bit more traffic with it. Makes it a little bit more difficult. So these are the parallel lines. We have 2 transversals. The transversals kind of intersect there together, which make it a little bit more difficult. But look at, they've got these 2 transversals. Just for a second here, I'm going to get rid of that transversal. Do you see how the 120 goes with the yellow and the green right there? We have another 120 degree angle right there. But it was chopped in half with those x's, right? So each of the x's has to be what? 60. You see that? But that got cluttered by the other line. So you have to, that 120 degrees goes with the whole of that angle. That corresponding angle is the x and the x together. So if those 2 are both 60, how are we going to find y? Well, with this transversal, we have same side interior angles, 60 and y, those are same side interiors, so those are supplementary. Y is equal to 120. We'll be working on this a lot in class next time for sure. But using this idea, see if you can figure out 1 through 6 here on your own. I'll do number 1 with you, actually. Check this out. Down at the bottom, those are, perpendicular angles, same side interior. What does 5x have to equal? Doesn't that have to be a 90-degree angle right there? So 5x equals 90. And then 6y and 3y, those are same side interiors. Whenever you have a kind of a closed off quadrilateral right here, you end up with, well, the name of this, there's a name for it. This is a trapezoid with 2 pair of parallel sides. These sides are same side interior. Same side interior. Supplementary angles. Try numbers 2, 3, 4, 5, and 6 real quick. These are answers. How you doing? I'm sure there's a few questions here, but see if you can figure out these the best that you can. All right, now I'm going to hop up here and do example 2 for you. That'll help you on the bottom 3 questions that we have. You've got parallel lines here on the left and the right, 2 more on the top and the bottom. This is called a parallelogram. When you have a parallelogram and then this transversal that cuts through it, I want to show you how that if we extend those lines, we end up with all sorts of corresponding angles and vertical angles, alternate interior angles. Here's a parallelogram with those lines extended. And look, this is just like we had earlier. All those angles congruent, all these angles congruent. Okay? And then if I put a transversal in there, all I end up with is way more angles that are congruent. I got congruent angles everywhere. That's what's going on down here too. To solve for x, this yellow line, and well, the orange line is the yellow line. These are alternate interior angles. For x is equal to 52 degrees. That's how we can solve for x. Similarly, with the blue line, yellow transversal blue line, we have congruent angles. 3y plus 8 equals 32, so y equals 8. Now, to solve for z, it's a little bit more confusing, but here's what I want you to realize. If this angle is equal to z, well, what is this equal to? Z, which means what's this equal to? Z, and this is z, 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 z. We have alternate interiors, corresponding vertical angles, make all of those z. And if this is 52, then this is 52, and so are those other angles. And if this is 32 up here, well, then this is 32, and those other angles are 32. So we filled in all sorts of these angles here. Now, look at this right here. Straight angle, z plus 32 plus 52 makes a straight angle, 180 degrees. Z is equal to 96 rather. Okay. There's other ways you can get these answers, but writing in what you know is really helpful, especially until you kind of get used to these patterns. All right, try those 3 questions out the bottom, and you're done. Okay, so number 7 is a lot like the one I just did with you. Actually, so is number 8 in a lot of ways, and 9. Has a lot to do with the parallelograms like we were just talking about. So, yep, be prepared to ask questions if you have them. Come see me if you have questions as well. This will get easier, and but hopefully it's making some initial sense. Get some rest. That was a long lesson. Bye-bye.